Okay, let's start. Good morning. Welcome to the second part of many parts. Today we're going to cover the basic. We're going to start diving into the language elements themselves, and we're going to start talking about the data types in JavaScript. It seems like a boring and mundane and completely trivial topic, and it's actually a boring and mundane and trivial topic. Yes. But I'll try to put as many inputs as possible about some quirks and how things actually work under the hood, if it's possible. There's not much to say about variables and data types to a bunch of developers. But we'll cover it anyway because it's important, and there are some differences from what you're used to how JavaScript handles things. So we're going to cover the basic data types that all of you are familiar with from other languages, like integers and floating points, Booleans and strings. And we're going to see how to declare them and how to assign them. Basic stuff, but important. So as you all probably know, computers use data, and that's what we use them for most of the time, to process data and information, which is stored in the memory. And we can define some containers, which we used to call variables, to hold this information. And this data can have different types, because basically what we do is we assign a bunch of the memory, and we put some bits into it, and we need to know, first of all, how much is assigned the size of this memory block. We need to know its size, and then inside it contains just a bunch of bits, zeros and ones, and we need to know what they stand for. So they can stand for different things. They can stand for whole numbers. They can stand for real numbers. They can stand for strings, text, whatever, and that's how we have to differentiate what's inside. So just as I just said, there are different data types. For example, positive integer numbers or alphabetical characters, and they're all represented in memory in the same way, and we need to store them somehow, and we need to know how to use them and how to manipulate them. JavaScript is much more, as I already mentioned in the previous session, JavaScript is much more permissive, and in terms of variables, it's quite typeless. There is only one variable type called var, and you don't even have to use this keyword if you don't want. We'll see some differences about using it or not using it, but every variable that you define by the keyword var, then you give it a name and assign a value to it. And it can be any value. In this case, for example, we have here a variable called count, and we initialize its value to the number 5. But then on the next line, we use the same variable to hold a string. And JavaScript doesn't care about that. And as I also mentioned in the previous session, even strings they can be defined with a single quote or a double quote. It doesn't matter. Holding numbers also, if you're familiar with floating point numbers from C#, for example, you have to differentiate what kind of number, floating point number you're defining, and what's its size and capacity and range. It could be a double, it could be a single precision, double precision, and so on and so forth. In JavaScript, you just write a number, and either you put a point inside it or not. It's just the same for the internal implementation. So let's start with the basic types, integer types. Integer types are whole numbers, as you all know. And just as with any numbers in any programming language, the range of the number depends on the size of the memory that we allocate to store this number. So same goes here. Actually, I think we're going to get it on another slide, but I'll just say it in advance already, because JavaScript the JavaScript standard defines that all numbers are double precision numbers. That means they're all 64-bit floating point numbers, regardless of how they look in the code, how you define and how you assign. Basically, they're all the same. And I want to, just a moment, if any of you wants, I'm not going to dive too much into how floating point numbers work, because it's a little bit heavy for today. But I want to direct you just one more second. If any of you wants to get a little bit more, what the hell? Okay, I got it. I'll tell you about this message also, because it's also related to what we saw last time. In my blog somewhere, I have here a bunch of .NET and C# recordings from the Academy, but one of them was talking specifically about floating point numbers. And since I felt the need to elaborate about the subject of how floating point numbers work, in one of those, there should be here. There is a post here that I've put about floating point numbers, which gives a breakdown by example how floating point numbers are represented in memory and how they work. And this is good for pretty much any programming language that you'll be using, because this is a uniform standard that works everywhere. So if you want to go deeper into how floating point numbers work, there are many online articles and videos, and if you want a deep dive, there's a very clear cut by example on my blog, so you can go there and see. Because I'm not going to dive too much into how floating point numbers work, but we're going to see some quirks which come from that. So basically, what I'm saying is that you can define numbers in JavaScript as integers or floating points. Just by the way, floating point numbers are numbers which are not whole numbers. Okay, they have a fraction, and they have a point which can be placed in different points in the number. We have a capacity of a large number, and we can split it up in different places and put a decimal point. So that's why it's called a floating point. So in JavaScript, all the numbers are of capacity 64. They consist of 64 bits, and they are defined as floating point numbers, regardless of what you define them. So this gives us an integer type within this range, which is quite large enough for many usages. And as you can see, let's just see some examples of this. So I've already opened this example in Visual Studio, and let's see it maybe like this. By the way, I'm going to share, of course, like the previous time, I'm going to share the recording and the demo materials. And specifically, this demo has some interesting script behind it, if you want to dive into that. As you can see, I have here a very simplistic HTML page with a div and a script. If we look at that script just for a moment, because it's a little bit of an overkill what's in this script, but I'm going to show it anyway. So if anybody feels the need to a little bit of a deep dive, they can check out the script of this demo. Because what it does, we have here a pattern which is very widely used in JavaScript, which is a self-executing anonymous function. So we are defining here a function and putting actually what we're defining is some kind of a class in this sense. And we are defining some methods to it and some properties. And in the end, we make it run. And what it does, it will create an object of itself inside this element on our page. It's a little bit complex, and like I said, I'm not going to dive into exactly what this code does and how it works, but for our need, what it does, it makes this div to be this kind of console, and on every call here, we're just writing a line of text into it. So it's useful as if you have a console that you can write lines into. So here we are defining a student, student count variable, and assign it the value 5. And we can see that its output is here. We have here another few integers defined. And wait, I'm losing myself here a bit. Yeah. That's it. We have a definition for the maximum integer and the minimum integer, and you can see that once we get to the maximum integer and add another 1 to it, actually the value stays the same, which is a bit of a quirk in this case. But I guess it's because of the representation of the number and the way that it's represented. We'll see more about numerical quirks, but basically, most of the usages that you'll have with integers will be something like this. Assigning a variable and filling it with a whole number and then using it for certain calculations or loops or whatever you need to count. That's the main usage of integer numbers. Again, stop me if something is not fully clear. Floating point numbers, as I just mentioned, are not whole numbers. They are real numbers. They have a decimal point in them, and they are, of course, used for all kinds of calculations that you might need, mathematical of any kind. And yeah, the fact that you have 32-bit floating point numbers or 64-bit floating point numbers, that could be they behave the same way. The only difference between them is the number of bits that each one defines in each part. Back to the idea of floating points, and what you can see on my blog post is the fact that actually floating point numbers are built in sections. Each part of memory is used for somehow to represent the number. It's not like you type 0.01 and the computer will take this as you write it and put it in memory in the same form. It will start manipulating it in a way that it will try to put it in memory in the way that it can represent all kinds of numbers. And this kind of representation gets all kinds of quirks and weird behaviors because actually the computer can't really get as accurate as your numbers are in every time. And many times it loses the precision of very basic things, very basic calculations. So here are a few floating point numbers and a few floating point number constants that you can use. For example, if we saw last time the math object that has a property of pi that returns a more or less precise value of the pi or p number. I think it's supposed to be p, by the way. We have the minimum value that JavaScript can produce and the maximum value. We have also values like infinity and minus infinity, and those can be also used in your code. You can use the word infinity as a keyword. And once you have calculations which are which fail, or by the way, if you're trying to parse a string that should contain a number, but it's not really a number, what you'll get is this thing, which is a representation of something which is not a number, which is sometimes good to check whether your variable has a number or no number. And there's a method called isNone, which will return true if your variable actually contains a number or contains this thing. So actually there are some examples here, but I wanted to show a few more of those. By the way, JS Fiddle, there are many online tools, but I use JS Fiddle a lot. It's very useful. If you need a quick notebook, just to write things and try things, to run them quickly to see how they work. There are many such tools, but JS Fiddle is one of my favorite. So for example, I'm storing here all kinds of examples from the other courses as well. Here's one example. You just have one field for HTML, one field for JavaScript, and one field for CSS. And once you run it, you get your result in the other quarter part. Have I shown it? Did I show it last time? No, I think not. So here are a few examples of bizarre calculations with JavaScript. What I've put here just to show is a simple HTML. I have a bunch of buttons, and on each one I'm showing the text of what I'm going to calculate, and then when you click it, I'm going to alert the calculation result, just to show what happens. So for example, here's a simple calculation. 0.1 plus 0.2 should be 0.3. But actually, when you run it in JavaScript, what you get is this number. Can you see it? It's almost 0.3, but it's not quite. One of the bizarre quirks of the behavior of how floating point numbers can get inaccurate, and how, because of the way that they're represented in memory, they can lose their precision in this case. Here's another example. So now I've put these two. So I'm going to calculate this first, and then I'm going to add this. So it should be something like 0.6. But it's almost, it's even closer than the other one to the actual number, but it's not quite. And once you do it the other way, it does get it right somehow in the end. So it's difficult to know. If you're looking for high precision with floating point numbers, you need to be careful, because there are some end points that you might want to avoid. We'll see about the other examples in a moment, because they're, I think, related to what we're going to see here soon. So this 0.1 and 0.2, I've seen it online in many places. It's a very common example to show how things work, because it's a very simple calculation, and it doesn't work nicely. Maybe there are more examples here. Yeah, it's the same ones that we've seen, same ones that we've seen just now in the slides. So I'm not sure there's more to see in the code. Just the value of pi that we're putting, the minimum and maximum values, which are shown here. Since they're large enough, they're shown in a shorter representation. Then the numbers infinity and minus infinity, which are productions of calculations, but can also be used, for example, to compare whether your result is infinity or not. You can see that you can use the keyword infinity. The not a number that we're getting in this weird calculation. What else do we have here? Epsilon. Nice. Okay. And here we have a Boolean trying to see whether the sums are equal. We'll talk about Booleans in a moment. I mean, is this clear? Do I need to go deeper into what we see here? Any questions about this? So as I mentioned, all the numbers in JavaScript are represented as floating point, double precision, 64-bit numbers. That's the standard. It doesn't relate to the operating system or the browser. If you follow JavaScript conventions, this should be the implementation. There is also an object called number, and there are other objects in JavaScript, just like we saw last time, like date, that are used here and there. But for trivial usages like number or string, you have objects that you can initialize like this, but there's absolutely no need to do that because they don't give any added value, and I think they also harm performance. Now about this, a conversion between floating point numbers and integers. Let's see, because I have it here on my fiddle. So there are a few ways to do that. First of all, we can use mathematical functions. These are the mathematical functions that they are the easiest ones to use, and they're the most trivial and the most useful and usable. So you can use floor to round down, or you can use the ceiling to round up, or you can use round, which will round either up or down, depends on your number. So this is how we take this number, and it's rounded down. It's rounded down with the floor method. Here it will be rounded up, so we get the number 4 in the end. Here it's rounded down because we have 0.35, we'll get it to the floor number, and here it will be rounded up because we have 65, and it's rounded to 664. Another way is to use the bitwise operator OR. This seems weird, and the reason that it seems weird is because it's weird. Yes, that's the reason. We haven't spoken about bitwise operators yet, but I guess most of you are aware that they exist, and they look like pretty much the bitwise operators that you're used to see. As I mentioned, data in variables is stored in binary format, a bunch of ones and zeros. There are logical operators like AND and OR that are used in conditions and loops when we want to check something, whether some things are acting the way you need to, and you can use those logical operators. There are also bitwise operators that take your data representation in bits as it is in memory and will transform them according to the logic of OR and other options like NOT or XOR. So what we're doing here is we're taking the representation of this number and we're doing a bitwise operation of OR. This line here represents the OR logical operation with the number 0. And what it does is actually it should leave the number as it is, because when you do OR with a 0, I think I'm right, you shouldn't change the value, because 0 or 0 will end with 0, 0 or 1 will give you 1, and 1 or 1 will give you 1. So 0 should not change the value. What it does actually with JavaScript, bitwise operations work only on 32-bit numbers. So when you do a bitwise operation, you actually cut the number into 32 bits and you get rid of part of your representation. This will give you an option to take a number like this, and if you do a bitwise operation or 0, you'll get the number rounded into a whole number integer. Again, it looks weird. It's a weird thing to do. It's not intuitive, and it doesn't always work. Because, here's an example, if the number is big enough and it's beyond the range of 32 bits, what will happen is that you'll lose your number completely. Because here's the result of doing this with this number. This is what you'll get. Because you get a cut down representation of your number into 32 bits, and that's it. Basically, it stays the same, but some just chunk of it is thrown away. And then it becomes an integer, but you don't know what integer it will become. If I take the same number and I do a mathematical operation, matfloor, we'll get the right result. So So what I want to say basically is that what you see here is weird, and don't do it. Unless you want to really mess with somebody's brain, look at your code and they'll say, what the hell is going on? That's how you do it. Okay? So I'm not sure why the examples here are sticking just to this example of doing this, but that's maybe to mess with your minds and ask questions. So I already gave you the answer. Black magic. Yeah, it is. Here's an example of how you can take a number and convert it to, how you can take a string and convert it to an integer. Again, this is not how I would do it, but once you make a numerical operation on a string that contains a number, JavaScript will be smart enough or dumb enough to try to follow what you're trying to do and convert things for you. The same goes if you take a number string and concatenate it to some string which doesn't contain a number, it will be converted to a string. So this is also a way to do it if you want to mess with somebody's brain, but that's not the best way to convert numbers into strings or strings into numbers. The right way to do that is to use the method called parseInt. So once I run this, we'll get the number. Well, it's a number now, but you don't know it's a number because it's going to be a string once it pops up. So let's add some numbers to it. But something that you will see that's happening. So I'll put a normal number here. And I'll add it to a number. And we get the sum of the calculation because what we've done here is converting this string to a number with a parseInt method, and that's the best way to do that. If you try to parseInt something that doesn't contain a number, for example, string which is not numerical, you'll get not a number. And if you want to check whether what you have, for example, if you take some, if you take some user input and you want to check whether the user has entered a number or not, you can try to parseInt, and then you can check whether is not a number. And in this case, it will return true. Okay, so again, this is the common way to convert strings to numbers, integer numbers. There's also a method parseFloat, which does the same for floating points. And there's a method isNotAnumber that will help you determine whether the number that the text, the object that you have converted into is a number or not a number. So where were we? There's a demo, another demo. Is there? Not sure, but there's something we haven't seen. We're moving on from numbers. Anybody wants more numbers? Okay. Sure. Well, the question is whether there's a type for currency or we should use floats. As far as I know, there's no special type in JavaScript for currency. Just. Yeah, it's not very accurate, but you have such quirks in other languages too. You'll get calculation abnormalities in C# as well. It's not about the language, it's about the representation of the number in memory. And as far as I know, there is no special variable type for currency in JavaScript. I'm 96% sure of that. I should say 96.6. Okay. Boolean types are simpler types than numbers because they contain only true or false. They're used to any kind of logical tests. So we want to check whether a certain condition exists. You can check and you'll get a true or a false. So of course you can define any variable, give it a name, and set it immediately to true or to false. The keywords are okay in this language, and they are both lowercase in JavaScript, unlike other languages. So for example, we have two variables here, a and b, 1 and 2. They are integer numbers, and we are assigning a third variable here, which will get the condition, which will get the result of this check. And this check will check whether a is larger than b. And in this case, it's not, so the result will be false. There's also a check here, another check if we want to check whether something is equal to something else. I think we're going to have more discussion about conditions and logical operations and conditional blocks. But in case you want to check whether a certain element is equal to another element, you do it with a double equal sign. Yeah, you know that also from other languages. So if you want to assign something, you use a single equal sign. If you want to check whether a certain condition, whether a certain element is a certain object is equal to another, you use a double equal sign. So in this case, we're checking whether a is equal to 1. It is, so we get here a value of true on this side, and we're assigning it to this variable, and what we'll get here in the output is true. Yes. Just as we saw on the slide. Something is not right here. Okay, so we're using the same console thingy that I showed earlier, just to write down the expressions instead of using the actual console of the debugger of Firefox. And again, here are two variables. Here's our condition. We could actually see how it runs here in Firebug. It would be maybe it will be useful for now, maybe not. So when we load, we get to our breakpoint, and right now we can see the value here is 1, the value here is 2, and the value of this expression, well, it won't show it, but if I go and make a watch for it, we can see the value is false. And when we assign it to this variable, we'll see that it's assigned the value, false. And we'll write it down in the console, this string, and this variable, which is a Boolean, but it will be converted to a string. So once we type it down, we'll see that it's converted to a string, and it's writing false on the screen. Same here, we want to check whether a is equal to 1. And here's the value. I'll copy it here, put it for a watch, and it's equal to true. And once we type it down to the screen, next we get it here, and then we print it down here. And that's what we get. Okay. One more thing that I'm not going to cover right now is just to mention quickly that, just a little anecdote right now, that there are two ways to check in JavaScript whether objects are equal. One is to put 2 equal signs, and one is to put 3 equal signs. If you want more equal signs, that's up to you, but 2 and 3 are what you should use. A deeper comparison of objects can be done with a triple equal sign. Just to mention that, because I think it will be mentioned in further sessions, but for today, for now, I'll just want to quickly say that because it wasn't mentioned here. Strings, also very useful. By the way, what you have here is the quote of the first phrase of the Bible. Yeah, I don't know. In other languages, maybe, but this is the first phrase of the Old Testament. In the beginning and all that. So strings. Strings, as we've already seen, are representing a sequence of characters. They're used to store text. They're very useful, of course, for anything pretty much that you might want to build. They can be in JavaScript. They can be both with a single quote or a double quote. So it all, of course, depends on what you need to store inside. Sometimes, if you want to put a double quote and you want to make your life easy, you wrap the string in a single quote and vice versa. JavaScript doesn't care. Concatenating strings is also a very easy thing to do. It's very difficult to see the bottom of the screen, but you just use the plus sign and you can concatenate strings into one longer string. What we see here is absolutely nothing new to what I just said. We have an example of 2 variables. They're both defined as strings. And we are concatenating an actual literal string to a variable which contains a string and to another string, so that we can build our strings like that. Of course, just like any other modern programming language, JavaScript works with Unicode, so you can store strings in any format, in any language, with any symbols. And as you can see here, you can also make your variables Unicode. I've never seen anyone do that, and I wouldn't recommend it, but it's seemingly possible. Because I mean, okay, maybe this is okay, but if somebody makes this a variable down here, it will be more difficult to read for some. Let's see some examples. Well, not much to see here, just as we saw in the previous slide. What we're doing, we're concatenating strings. So we have here an actual literal string that we're concatenating with a variable. So we have to enclose our first string with double quotes or single quote, and then we can concatenate strings with plus signs. And that's how we can take a variable that can come from the database, from the server, from anywhere, from the user input, and we can concatenate it into one larger string. And this, of course, one of the most useful things to do for any application. Once we have concatenation, of course, it's a common mistake. You need to put spaces in between because nobody will do it for you. So once we concatenate strings that we need to be spaced between, we need to also specify that they're spaced. Otherwise, they'll be in one long one. And these are some Unicode representations also of variables. And you can see that they all work. So you can use Unicode pretty much anywhere you need. Okay, about strings. Have a little bit more to go. Undefined and nulls. We'll start with the easy one. Null is usually a value of an unassigned variable, so that okay, so once we have a variable and we don't assign anything into it, we can also manually assign the value of null. It means that the variable is defined, but its value is currently empty. It doesn't contain anything important or anything at all. If a variable is, variables can also be undefined, or if a variable is really not defined in the scope of your code, you can check whether it is equal to, if its type is undefined. It's something unique to JavaScript because variables can come from anywhere, and names of variables can be coming from your global scope or from external files. And since JavaScript is not compiled, if JavaScript was a compiled language, you would get errors in your build. Once you try to build and compile your code, you would get you'll get compile time errors that you're using a variable that doesn't exist, or that you're using the wrong name, or things like that. But JavaScript, of course, is not compiled. It's only interpreted in runtime, and variables can come and go from different places. And one example of that is that different browsers implement JavaScript differently. And for example, when we try to interact with our DOM document, when trying to interact JavaScript with the HTML, in some cases, some browsers will define certain objects that you can interact with, but other browsers will define them differently. So in some cases, you can try to check whether the variable you're trying to access is undefined. It means it's not existing at all for this browser, so you shouldn't interact with it. So that's one of the usages of checking whether something is defined or not. I mean, in your code, there should not be, I mean, in the code blocks that you build, there should not be undefined elements, basically. But you can check whether external things that you're using, for example, integration with the browser objects that are given to you, are defined or undefined. So that's the importance of undefined. Which, by the way, if I go back to my notebook, if I check something like this, I'm just jumping ahead to conditional statements just for a moment. Don't like it like this. That's better. So if I have an if block like this, and I'm checking this variable, it will be checked whether it's defined and whether it has some value. I mean, if it's null or undefined. So we can see that. I'll just show it in a moment. So I'll put two alerts, one here and one here. Just to see the result. Oh, no, don't save. So since the variable x is currently undefined, we're not getting anything at all. Okay, let's try this somewhere else. Still not. Okay. price. Well, something is wrong here because okay, forget about this example. It's not working as I expected, although I have to check why. But actually, just a moment, sorry about that. Let's take a look at this one. Okay, so what we have here is, again, we're defining a bunch of variables, and what we're typing is the output of the method type of, which will give us the type of this variable. So in this case, you can see that once we define an integer or a floating point number, both of them are represented by the type number. As I mentioned, they're all underlying the same representation in the language. Then we have a variable. Actually, we are using the same variable again and again. So we are just giving it different values. We can manually set a variable to be undefined by setting its value to the keyword undefined, and the type will be undefined. We can set it to null, and then the type will be actually an object, but it's an empty object in this case that can be used as properties. Then we can set it to a string. Then the type that will be detected is a string. And as I mentioned, you can use the object which represents a number by using a constructor and using the keyword, the class name number. Then you'll get an object, but as I mentioned, it's pretty useless to use number objects. I think that's about it for this part. So variables are pretty much what we've seen since the beginning today. Storing data and storing information. It could be any of those types that I just mentioned, not counting classes and objects that we still haven't covered, but all the built-in language types like numbers and strings, undefined objects, and nulls and numbers. So as I said in the beginning, we have the var keyword, which defines a variable. And once you define a variable, if we're talking in terms of code blocks, once you have a variable, it's alive within the block of the code in which it's defined. So here's the notation. You put the word var, then you set an identifier, and you may or may not initialize it to give it some value. As you can see here, the var, we put a variable called height, and we set its value to 200. Identifiers can be letters, underscores, numbers, digits, the $sign. And it's not exactly true that it can begin only with a letter or underscore. It can also start with a $sign. And this is used, of course, in jQuery. jQuery has taken advantage of using the $sign as a named variable. So it's actually the entry point to using all the jQuery all the jQuery functionality using $. And it's also common practice here and there, whenever you have a variable which is initialized with something that comes from jQuery, to start its name with $. So you will know that this is a variable which relates to jQuery data. Of course, you can't use keywords as variable names. You'll get in trouble. And the notation of variables, whether it's camel case or something else, is up to you, but standards are with camel case, which means the first letter is lowercase, and if you have multiple words, you put them together with an uppercase letter. It goes without saying, when you're putting variables, give them names that have some meaning, so especially something that will be in context of what they're used for, so that somebody comes to see your code will understand why you're using a variable there and what's the meaning of it. Don't put it too short, don't put it too long. Use Latin letters because you don't know who's checking your code. And variables are case sensitive in JavaScript, just like in C# or Java. So you need to be aware that your variables are used with the right casing. So some examples, we have some variables here, not much to show. As I said, you can use any name. This one would stand out because it has an uppercase letter starting. It's not very common. But if you use a lowercase new, then you'll get in collision with a new keyword which is used in JavaScript, and that will be a problem. You can begin a variable with an underscore, but if I would remove the underscore here, I'll get a variable which starts with a number, and that would also be a problem. You can use Unicode, as we saw, to define your variables, but it's also not recommended. So the good way to do this, put a var, give it a normal name that somebody will understand what it is for, and initialize it, and with the right appropriate value so it won't get completely lost, and that's it. So great, this demo doesn't have an output, which is the best type of demo in the whole world. So, instead of a black screen, actually what we see here is a copy of what we saw in the slide. We could take a look at what's going on in runtime just to cover it. So here's our code. Let's reload it. So over here we can see that the watches of Firebug is already analyzed the code, and it gives us some of the variables that we're using here already lined up. So once they get assigned, for example this one, and can you see anything? So once we run this line, we can see that this is already initialized, and we can see its value, and so on and so forth. We can see now that the values are being assigned to those. By the way, I wouldn't necessarily consider this an over-descriptive identifier. Sometimes it's needed. I'm a fan of long names that tell you exactly what they're for. Okay with this? So as we've seen already, we're a bit repeating, assigning values to variables with the equals operator. You can do it while you define the variable, you can do it any other time. Once the variable is alive, you can reassign values to it. So here we have 3 variables. And we start reassigning values to them. What's interesting here, by the way, yeah, in this case, what we have is a copy of the value between the variables. So we have the first one initialized and the other 2 not. And once we have them running, we can reassign values between them. We can also do a 3-way assignment, like down here, although it's not very intuitive, so shouldn't be used. I actually have never seen. I haven't seen much 3-way assignment like this. It also works in other languages. I haven't seen it much used, and I think I know why. Anything special to say about this slide? No, so much. So here are some examples which are pretty similar to all the examples that we've seen so far. Assigning variables with the var, name, value, and reassigning them between themselves. I'll just skip to the next one because I don't think there's any more to keep talking about assigning variables. The only thing I want to mention here is the fact that you can assign variables, as I mentioned in the beginning, with the var keyword, but it's not necessary to use the var keyword. You don't have to use it. You can just take a variable and start assigning it. The point is that if you assign a variable without the var keyword, since JavaScript will not know where it's actually coming from, it will treat it as a global variable, which means it will live beyond the scope of your code blocks. Sometimes it's useful. For example, if you're building an external library like jQuery and you want to build some kind of a global thing that people can reuse, then you can define it maybe as a global. But in most cases, once you define variables in your code, they have a specific lifespan, a specific area of the code where you need them. So in this sense, you have to think where you're defining them and give them the var keyword in the declaration so that they're alive only in the scope of their own code. Also, you have to be aware of double declaration because you can redefine a variable once it's there. Again, JavaScript will not care about it. It will not give you a compile time error that you're redefining a variable because there is no compile time. And it can give you a problem if you're not cautious enough and you're giving a variable, you're redeclaring variables in your code with the same name in the same scope. I think that's all there is to it. Questions? This one? Yeah, except that here it says var, and here you're just defining the variable without var, so it's becoming global. So you don't know what you're running over, and it's a problem. And by the way, yeah, if you define a variable with a var which collides with a global variable which already exists without the, I mean a global variable that your code block has gotten, I think it will not get overridden. I think so. Let's check it out just in case, because I had some surprises today. But that's the whole idea, right? What I want to check is this. So let me think about something. put a code block here. And another variable with the same name out here. And I want to see what will happen here. And what will happen here. So we get the variable from in this block, which is defined with a var and should cease to live outside. And we actually overridden the global variable. So be careful, because variables can be redefined and overridden. I think in a function it will behave maybe better, because functions are actually defining also classes in JavaScript. Oh, no, don't give it the same name. Let's see now. So instead of just running through the code, I've defined a function, and now I'm calling the function, and once we're done, we're back to the external scope. So now we get the inner function code running, and now we get the outer. Yes? Good catch. Any more? One of the lessons from the HTML course that people gave a feedback that they needed more exercise to do on their own. So we're sharing now in the Academy's Knowledge Hub those PowerPoint presentations, and in the end there are exercises if anybody wants to try to play with things themselves, because we don't have much time to exercise in those sessions. Questions from you before we close it for today? Okay, so thanks guys. See you next week.